right. Welcome to Learning System Design Day One or Part One or whatever you want to call it. This is just going to be me walking through some system design problems. Um, I'll find maybe an article or some kind of resource with some system design um, for a system design question breakdown. And I'm just going to walk through it and kind of talk about what I think. If there's anything I want to add, I'll do that. I'll just sometimes I'll just read through the problem and kind of walk through it. And I feel like this is a good way for me to learn. And then also hopefully anyone who is watching might get something out of this. But yeah, let's go ahead and start. This is on hellointerview.com. We're going to look at design online auction. I'm guessing this is a pretty common question. Hello Interview likes to cover a lot of these likes to cover a lot of common questions. So I find that these kind of questions are a good place to start. All right, so understand the problem. So online auction service such as eBay, um, it lets the users list items for sale while others compete to purchase them by placing increasingly higher bids until the auction ends, with the highest bidder winning the item. Okay, that makes sense. Something like eBay, you can um, auction, place bids on items. You might get outbid or you might even win an auction. That's not all there is to eBay, but that is the auction component of it. So let's go ahead and take a look at functional requirements. So users should be able to post an item for auction with a starting price and end date. Makes sense. Users should be able to bid on an item. Makes sense. Users should be able to view an auction. That makes sense. And then these are just some of the out of scope requirements. Users should be able to search for items. Users should be able to filter out items, sort items, and then view the auction history. Of course, like in any system design question, you can include these stuff. Um, it just depends on how the interviewer wants to take it, or how you, as the interviewee, wants to kind of tackle the question. But this one, the scope is design online auction. So we definitely just want to focus on the auction part. All right, let's take a look at the non-functional requirements. The user should maintain strong consistency for bids to ensure all users see the highest bid. And this makes sense, right? You want strong consistency. You don't want to see stale bids. You don't want to see old bids. Like, you really want the most up-to-date data on the bids that are being placed. And so this is definitely like the number one core requirement, in my opinion. The system should also be fault tolerant and durable. Makes sense. You don't want a bid to be placed and then canceled or not get submitted, because this is a pretty fast. Like, sometimes it's a pretty fast moving system, so it should be fault tolerant. The system should display the highest current bid in real time so that users know what they are bidding against. Um, yeah, makes sense. And the system should scale to support 10 million concurrent auctions. And then these are just out of scope non-functional requirements. Um, should have proper observability and monitoring. Should be secure, protect user data, and should be well tested and easy to deploy. All right, that makes sense. So far, so good. So let's go ahead and take a look at the core entities next. Okay, so for the core entities, we want to have an auction entity, represents an auction for an item, include information like starting price and date and the item being auctioned. We want the actual item itself. We want an entity for the bid, which represents a bid on an auction. And we want an entity for the user. Okay, I'm trying to think if there's like any others that should be mentioned. I think you want like 3 to 4 core entities in every system design problem. I feel like going above that might be um, maybe an overkill, but yeah, I think these make sense. Um, and then let's move on to API. Obviously, because our number one requirement is being able to post or to bid on an item, we want a post request or a post endpoint, which is going to take the auction details, and it's going to return a created auction. Oh, sorry, this is not for bid. This is to actually create an auction. And then for bid, you would pass in the auction ID, um, and then create a bid request or a post request, which is going to return just the created bid. And then if you want to view auctions, we're going to have like a get request, which is going to take all the auctions based on the auction ID. Um, and it's going to return the auction item and details. So this is for a specific auction, not like getting all auctions. So yeah, that makes sense. All right, let's move on to the fun level. All right, let's move on to the fun stuff, which is the high level design. So users should be able to post an item for auction with a starting price and end date. Um, and if we zoom in on the design, we can see we have the client. There's going to be some kind of API gateway with routing authentication. There's going to be an auction service where the user can make a post request to the auction service um, to, I'm guessing this is to create an auction. Um, and then in our database, we're going to have an auction table, which is going to have ID, item ID, start time, end time, created ID, starting price. And then we're going to have an item entity, which is going to have ID, name, description, images, link. So um, the auction service connects to a database that stores the auction and item detail outlined in the core entities above. So this service, this auction service, is going to handle reading and viewing of auctions, uh, which makes sense. So um, yeah, I guess I'm confused by. Okay, so first things first, users need a way to start a new auction. Okay, so this diagram is to start an auction, which makes sense. So uh, you make you make a request to this post endpoint, um, and then it's going to hit this auction service, and it's going to create an auction with an auction ID and this entity, and then for that specific item, you need the item details. So the client user will interact with the system through the client's website or app. All client requests will be routed to the system's backend through an API gateway. Um, the API gateway will handle requests from the client, including authentication, rate limiting, and most importantly, routing to the appropriate service. The auction service at this point is just a thin wrapper around the database. It takes auction details from the request, validates them, and stores them in the database. And then the database stores the auction items or the auctions and items. Yeah, so uh, yeah, that makes sense. Pretty simple. This part of the design is just a basic CRUD application, but let's still be explicit about the data flow. Walking through exactly what happens. So client sends a post request to auctions with auction details, goes to the API, which routes it to the auction service. The auction service will validate the request. Data service will store the auction item and details. Makes sense. And then the second service is allowing users to be able to bid on an item, um, where bids are accepted if they are higher than the current highest bid. So if we take a look at the design, we're going to have a second service called bid service. Um, we're going to have some kind of API, which is going to create the bid. It's going to hit that database. Um, and it's going to store a bid, which is going to have an ID, auction ID, price, user ID created at, and some kind of status. Um, yeah, so pretty much like the auction service, it's going to have a client, API gateway, bidding service, and database or service. In this case, it's a bidding service. Um, and I'm trying to see if there's anything different. Okay, so we choose to separate bidding into its own service for several key reasons: independent scaling, isolation of concerns, and performance optimization. So if you're familiar with like microservice architecture, this makes sense. You want the bidding to happen in its own um, service as it's how you want it. It's best for scaling. Bidding traffic is typically higher than the auction creation. Um, it also isolates some of the complex business logic around validation, race conditions, real-time updates. Keeping it separate helps maintain clean service boundaries. And and just being able to optimize the bidding service specifically for high throughput write operations. while the auction service can be optimized for read-heavy workloads. So yeah, so uh, as far as like our design, high-level design goes, this is pretty simple. And this is certainly like, I'm gonna guess this is more of an easy question if you were to, um, if you were to ask me. I wonder. Oh, okay, so it's medium. So in terms of difficulty, they rate this as a medium. I'm guessing because of the some of the deep dives, there's more complexity there. But let's go ahead and continue. So users should be able to view an auction, including the highest bidder. Um, so they want to learn about the item in case they decide they're interested in buying it, and they want to place a bid, so they need to know the current highest bidder. These two are similar but have different requirements. The first is a read-only option. The second requires real-time currency, or sorry, real-time consistency. We'll upload the depth of discussion here to our deep dives, but let's outline the basic approach, which ensures that the current highest bidder is at least reasonably up to date. Yes, I would say this is a medium level question, mostly because of the way we're going to handle the different, or the way we're going to handle the bids. We're going to have a lot of bids coming in for an item, and and I'm going to guess that's going to be where the the medium difficulty comes in. So when a user first goes to view an auction, they'll get a get request to auction ID, which will return the relevant action and item details to be displayed on the page. Makes sense. Okay, so yeah, that is the high level design. So we have just to look at it one more time: auction service, bid service, it's that database, and then we're going to have a client API gateway, which is pretty standard for these kind of questions. All right, so the deep dive is going to start with consistency for bids. As we outlined in our non-functional requirements, strong consistency is very important. So um, let's go ahead and read what they have to say for this. Ensuring the consistency of bids is the most critical aspect of our design. Um, the current highest bid is $10. When a user decides to place a bid for 100, user B decides to place a bid for 20 afterwards. We need strong consistency. Without proper concurrency control, the sequence of operations might unfold as follows. User A's read is 10. User A writes their bid of 100 to the database. The system accepts the bid because 100 is higher than 10. User B reads the current highest bid due to a delay in data propagation or read consistency issues. They'll see the highest bid as $10 instead of 100. So they're basically talking about why we need proper concurrency control, because we don't want user B to see that the highest bid is 10 due to some kind of delay. We want there to be strong consistency so that whenever user A bids $100, user B sees that it's $100. So as a result, both bids are accepted, and the auction now has two users who think they have the highest bid. So this is what we're trying to avoid. Um, and so the nice thing about Hello Interview is that they give us, like for these deep dives, they give us like three different ways to solve this issue. And so for bad solution, row locking with bids query, one initial approach might be to use row level locking with a query. Um, so if you know about distributed locks, basically you lock in whenever a user makes a transaction, the row is locked. Um, and so as it's saying here, here's how we can implement this: begin a transaction, lock all bid rows for the auction using select for update. This locks existing bids for the auction. Um, query the current maximum bid from this bids table. Compare the bid against a new one, write the new bid. If it's accepted, commit the transaction. Um, and so they're saying like this is not going to work because there might be some performance or scalability issues and poor user experience. Locking all bid rows for an auction serializes bid processing, creating a major bottleneck. So yeah, basically when you're dealing with like many auctions and many bids, um, it's going to be difficult to scale up, um, leading to increased latency and poor user experience. Um, so this would be the bad solution, using row locking. A better solution would be cache max bid, which I actually don't know uh, what this approach is. So let's go ahead and read it. The next thing for most candidates is to cache the max bid in memory. They realize that the main issue with the above approach is that we're holding the lock on a large number of rows for a reasonable duration. Since we need to query the bid table to calculate max bid each item, to avoid this, we can cache the max bid in memory in something like Redis. Um, Read the max bid for the given auction from the Redis. To avoid this, we can cache the max bid in memory in something like Redis. Now the data flow, when a bid comes in, will read the cache for the max bid. It'll update the cache if the new bid is higher. Um, and then it'll write the bid to database with a status of accepted or rejected. And so the challenge for this, I'm guessing, is that it's going to be related to scaling. But let's see. We've moved this from a consistency problem within the database to a consistency problem between the database and the cache. We need the cache read and write to happen. Uh, um, so we don't have a race condition like. Unfortunately, this is easy enough. We could use either Redis transactions or Lua scripting to ensure a read, modify, write sequence happen as one operation. We need to make sure that our cache is strongly consistent with the database. Otherwise, we find ourselves in a place where the cache says the max bid is one thing, but the bid is not in our database because of failure or any other issue. Um, so it's basically saying that we cache the max bid, but sometimes I'm guessing like I guess they're saying this is a fine solution, but there might still be a scenario when that bid isn't in our database. We need to make sure that our cache is strongly consistent with the database. Use distributed transactions to ensure atoms cross Redis and database add significant complexity. Except, okay, so this I'm not. I'm guessing like the reason you don't want to use a cache is that if you're writing to a cache, you might still be reading from. Um, you might still be reading from like a because if a bid is not placed in the database, we might still be reading bad data, but I'm not exactly sure. Let's read the great solution. So cache max bid and database. So we solved the issue with locking a lot of rows for a long time by moving the max bid to a cache, but that introduced a new issue with consistency between the cache and the database. Okay, so the reason why this is a good solution but not a great is that um, there's an issue with consistency between the cache and database um, because um, when we do the cache read and cache write, it might not be consistent with the database. And so in this solution, we're basically we're using the database as our cache. Um, so we lock the auction row for the given auction. We read the max bid for the given auction from the auction table, write the bid to a database with a status of accepted or rejected, update the max bid in auction table, and then commit the transaction. Um, so yeah, so they're saying a cache is a fine solution, but there might be consistency issues. So we're just going to use the database as our cache. And so as I'm thinking about this, I'm wondering, like, is this good for scaling? But I'm guessing it is because if it's reading from that auction table, then um, it shouldn't be a problem. So yeah, this is definitely one area I need to do some more research on because I kind of understand what they're saying, but not like I don't fully understand it. And so this is one place where I'm gonna have to dig a little bit deeper in. Um, all right, so let's move on to non-functional requirement number two, which is how can we ensure that the system is tolerant and durable? You don't want you don't want your system to drop bids. So like if you're trying to bid on an item and the bid gets lost, then that would be, as you're saying, catastrophic for trust in the platform. And so the best approach is using some kind of durable storage and buffering against the load spikes. Um, the best solution here is to introduce a durable message queue and get bids into it as soon as possible. And so yeah, these are the two benefits of using a durable message queue. It has durable storage in it, and there's buffering against the load spikes. And then there's guaranteed ordering. So if we take a look at our design, um, whenever so this is going to be the producer. Whenever a bid is created, it gets consumed or it gets put on the messaging queue, and then our bid service is going to act as a consumer. So it gets read off this queue. Um, and then we're going to use Kafka because there's high throughput. It can handle millions of messages per second. There's the benefit of durability. It persists all messages to disk and can be configured for replication. And it's as partitioning, we can partition our queue by auction ID, ensuring that all bits for the same auction are processed in order while allowing parallel processing of bids for different auctions. Um, and so the way this works is that a user will submit a bid. Um, if we take a look at our design again, a user will submit a bid. API gateway routes to a producer, which immediately writes the bid to Kafka. Kafka acknowledges the rights, and then we can tell the user that their bid was received. If the bid service will then consume that message from Kafka at its own pace. If the bid is valid, it's written to the database. If the bid service fails at any point, the bid remains in Kafka. So I would say this is pretty like easy to understand, and I think it will definitely create a system that's tolerant and durable. How can we ensure that the system displays the current bid in real time? Um, right. So this is also going to be important because we don't want, we don't want users who are looking at the auction to see like outdated bids. Um, and we don't want them to see outdated bids. We don't want it to be slow or inefficient. And the current solution they were using was polling, which is kind of like it's like it's using the API to figure out okay like what is actually let me see something here. I like to do this whenever I have like a question. So polling is a communication method where a client repeatedly sends requests to the server and checks for new updates. Right. So they're saying this isn't going to be a good solution because we don't want to keep sending new requests every time. It's going to be too slow and inefficient. And so a great solution is to use server-side events, which provides a unidirectional channel from server to client, allowing the server to push updates whenever they occur without requiring the client to pull. So it doesn't have to continuously send requests. Um, it's unidirectional, so the server will keep pushing the updates as long as they occur. Um, and so when a user views an auction, their browser establishes a uh, server-side connection or server-side event connection. The server can push new maximum bid values through this connection whenever they change. This creates a true real-time experience while being more efficient than regular polling or log polling. And then the good solution they gave was for long polling, which is a significant improvement over regular polling um, by maintaining an open connection. But the challenge for this, I'm guessing, is that it's is not as efficient. So the server must maintain open connections for all clients. Yeah, so you're always going to have some kind of connection that needs to be opened. Additionally, if many clients are watching the same auction, we might face a thundering herd problem where all clients attempt to reconnect simultaneously. So, okay, yeah, so that's why server-side events is the right approach. And this is something that's good to know as well. So they have a link to a Wikipedia article. But this is just one of those concepts that for system design, it's important to know because it's something that you can mention in the deep dive or even for some questions in the high level design. So um, yeah, so that was non-functional requirement number 3. And then I believe this is the last one. Um, How can we ensure that the system scales to support 10 million concurrent auctions? Um, so we use a messaging queue, which is pretty standard. Um, Bid service. So we're separating the auction service and bid service. And then for the database, um, yeah, I guess these are the solutions. It doesn't really tell us like what to use, but let's go ahead and look at the uh, high level designs. Okay, so it introduces a pub sub. So um, let's see. The solution is PubSub, whether using technology like Redis, PubSub, Kafka, or even a custom solution. We need to broadcast the new bid to all relevant servers so that they can push their update to their connected clients. Okay, so this is saying whenever someone makes a bid, um, all other instances of bid service are subscribed to the same PubSub channel and receive the same message. Okay, so this is saying um, we add more servers for the bid service, and then we use PubSub to scale it up by having the different services subscribe to the publisher so that whenever a bid is added, it gets sent to all the relevant servers so they can push their update to their clients. So when server A receives a new bid, it publishes that bid to the pub subsystem, essentially putting it on the queue. All other instances of bid service are subscribed to the same pub subs channel and receives the message. Yeah, so we want to scale up by adding more servers for our bid service, and then we're going to introduce a pub sub so that whenever a bid is added, all the other instances also know that it's added, and this is done through a pub sub. So that makes sense. Um, okay, yeah, I think overall that is the design. I thought this was I would say this is definitely a medium level problem. Maybe even like medium to hard, like uh definitely like a medium hard problem. And I would say it's because like um if you're new to system design, there are some concepts here that you might not be familiar with. And I think like this solution where you're caching the max bid in a database, I don't think that's something you're going to come up with if you don't have like a lot of experience with system design problems. So yeah, I'd say this is a medium hard problem. And I do like this write up. I think it's good. Um, all the answers they give make sense, and I think yeah, this is definitely one of those questions that you should know because these auction type questions do come up, and it's you can learn a lot from these questions too. So yeah, so that is it for this quick. I shouldn't say quick. Okay, so that is it for this video where I just go over a system design problem. Um, if there's anything I missed or if there's anything that I wasn't right about, or if you have any comments, just leave them below. And yeah, continue to follow along to this channel where I'll put more videos about system design, going over system design questions or any other kind of videos. So yeah, thanks for watching.